Circuit breakers are designed to trip when the current exceeds a certain threshold for a sustained period, accounting for amp spikes during device startup. Circuit breakers generally withstand brief amp spikes. To measure the main current, use a clamp-on ammeter, which measures current around the wire without direct contact. For a 50 amp circuit, expect to see 6 American wire gauge copper wire. For a 100 amp circuit, expect 2 American wire gauge copper wire. A 50 amp circuit should handle a continuous load of 50 amps, powering devices drawing up to 50 amps simultaneously. If a 50 amp circuit trips when turning on all heaters and lights, possible causes are firstly loose connections. Check connections at the main breaker, electrical panel, and devices. Secondly, an overloaded circuit. Ensure no additional devices are plugged in. Thirdly, defective devices. Test heaters and other devices. Finally, undersized wiring. If the wiring is smaller than recommended, it could overheat and trip the breaker. Firstly, let's discuss amp spikes. When electrical devices, particularly those with motors or heating elements, start up, they often draw a surge of current that is significantly higher than their normal operating current. This surge is known as an amp spike. Circuit breakers are designed to tolerate these brief amp spikes without tripping. They have a time current characteristic, meaning that they can withstand high currents for short durations but will trip if the current exceeds a certain level for a sustained period. This is important because it allows devices to start up without immediately tripping the breaker, while still providing protection against overloads and short circuits. The specific time current characteristic of a circuit breaker is determined by its type and rating. Different types of breakers are designed for different applications and have varying response times to overcurrents. For example, some breakers are designed to trip very quickly in response to a short circuit, while others are designed to allow for brief overloads, such as those that occur when starting a motor. Secondly, how to measure main amperage. Measuring the current flowing through the main circuit breaker is a crucial step in diagnosing electrical problems and ensuring that the electrical system is operating within its safe limits. The clamp-on ammeter is the ideal tool for this task because it allows you to measure the current without having to make direct contact with the wires. This is important for safety reasons, as direct contact with live wires can be extremely dangerous. To use a clamp-on ammeter, simply open the clamp and place it around the wire you want to measure. The ammeter will then display the current flowing through the wire. It is important to ensure that the clamp is fully closed around the wire for an accurate reading. When measuring the main current, it is important to measure the current on each of the hot wires feeding the panel. In a typical 240-volt system, there will be 2 hot wires. The current on each wire should be roughly the same. If there is a significant difference in current between the 2 wires, it could indicate a problem with the electrical system. Thirdly, let's investigate wire gauge. The American wire gauge, abbreviated as AWG, is a standardized system for measuring wire diameter. The lower the AWG number, the thicker the wire. The appropriate wire gauge for a circuit depends on the amount of current that the circuit is expected to carry. Using wire that is too small for the current can cause the wire to overheat, which can lead to a fire. The National Electrical Code, NEC, specifies the minimum wire gauge for various circuit amperages. For a 50 amp circuit, the NEC typically requires 6 American wire gauge copper wire. For a 100 amp circuit, the NEC typically requires 2 American wire gauge copper wire. It is important to note that these are just minimum requirements, and it may be necessary to use larger wire in some cases, such as when the wire is run over long distances or through hot environments. To determine the appropriate wire gauge for a specific application, consult the NEC or a qualified electrician. Next, about circuit capacity. A 50 amp circuit should be able to handle a continuous load of 50 amps. This means that it can safely power devices that draw up to 50 amps, including all of the lights and heaters in the apartment at the same time. However, it is important to note that the NEC recommends that circuits not be loaded to more than 80% of their rated capacity on a continuous basis. This is to prevent overheating and to ensure that the circuit breaker does not trip unnecessarily. Therefore, A 50 amp circuit should ideally not be used to power devices that draw more than 40 amps continuously. If you need to power devices that draw more than 40 amps continuously, you should install a larger circuit. Finally, about troubleshooting. If a 50 amp circuit is tripping when you turn on all of the electrical heaters and lights, it could be due to, firstly, loose connections. Loose connections can create resistance, which can cause the wires to overheat and trip the breaker. Check the connections at the main breaker, the electrical panel, and the devices themselves to make sure they're tight and secure. Secondly, an overloaded circuit. An overloaded circuit occurs when the total current drawn by all of the devices and the circuit exceeds the circuit's rated capacity. Ensure that no additional devices are plugged into the circuit. Thirdly, defective devices. Defective devices can draw excessive current, which can cause the breaker to trip. Test the heaters and other devices to make sure they are functioning properly. Finally, undersized wiring. If the wiring is smaller than the recommended gauge for the circuit, it could be overheating and causing the breaker to trip. If you cannot resolve the issue yourself, it is recommended to contact a licensed electrician for further investigation. They can perform a thorough inspection of the electrical system and identify the cause of the problem. Some additional points to consider when troubleshooting circuit breaker tripping issues are the type of circuit breaker. There are different types of circuit breakers, such as standard thermomagnetic breakers, ground fault circuit interrupters, GFCIs, and arc fault circuit interrupters, FCIs. Each type of breaker is designed to protect against different types of electrical faults. Make sure that you have the correct type of breaker for the application. Also, consider the age of the circuit breaker. Circuit breakers can wear out over time and may become more susceptible to tripping. If the circuit breaker is old, it may be necessary to replace it. Also, consider environmental factors. Environmental factors, such as temperature and humidity, can affect the performance of circuit breakers. If the circuit breaker is located in a hot or humid environment, it may be more likely to trip. It is important to address circuit breaker tripping issues promptly to prevent potential safety hazards. If you are not comfortable working with electricity, it is best to consult a qualified electrician. When dealing with electrical systems, safety should always be the top priority. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate safety gear, such as gloves and eye protection. If you are not sure how to do something, ask a qualified electrician for help. Regarding the specific scenario with electrical heaters, it's essential to understand how these appliances draw power. Electrical heaters typically use resistance to generate heat, and they can draw a significant amount of current, especially during startup. When multiple heaters are turned on simultaneously, the combined current draw can easily exceed the capacity of a 50 amp circuit, leading to the breaker tripping. When evaluating the electrical system of a new construction property, it's crucial to ensure that the wiring and circuit breakers are properly sized to handle the expected load. This is particularly important in rental units, where tenants may not be aware of the electrical system's limitations. A thorough inspection by a qualified electrician can help identify any potential issues and ensure that the electrical system is safe and reliable. Also consider the use of energy-efficient appliances. Energy-efficient appliances draw less current than traditional appliances, which can help to reduce the load on the electrical system. When replacing appliances, consider choosing energy-efficient models. Also, consider load balancing. Load balancing involves distributing the electrical load evenly across different circuits. This can help to prevent overloading any one circuit. To balance the load, try to avoid plugging too many high current devices into the same circuit. If you are experiencing frequent circuit breaker tripping issues, it may be necessary to upgrade the electrical panel. Upgrading the electrical panel can increase the overall capacity of the electrical system, which can help to prevent overloads. If you are considering upgrading the electrical panel, consult a qualified electrician to determine the appropriate size and type of panel for your needs. Remember, electrical work can be dangerous, and it is always best to consult a qualified electrician if you are not comfortable working with electricity. An electrician can safely and effectively diagnose and repair electrical problems. They can also ensure that the electrical system is up to code and meets all safety standards. The National Electrical Code (NEC) is a comprehensive set of standards for electrical wiring and equipment. The NEC is updated every 3 years, and it is important to ensure that your electrical system complies with the latest edition of the NEC. A qualified electrician can help you to ensure that your electrical system meets all NEC requirements. Grounding is an essential safety feature of electrical systems. Grounding provides a path for fault current to flow back to the source, which helps to protect against electrical shock. Make sure that all electrical outlets and devices are properly grounded. Ground fault circuit interrupters (GFCIs) are designed to protect against electrical shock. GFCIs monitor the current flowing through a circuit and will trip if they detect a ground fault. GFCIs are typically required in bathrooms, kitchens, and other areas where there is a risk of electrical shock. Arc fault circuit interrupters (FSIs) are designed to protect against electrical fires. FSIs monitor the current flowing through a circuit and will trip if they detect an arc fault. Arc faults can occur when there is a break in the insulation of a wire, which can create a spark that can ignite nearby materials. FSIs are typically required in bedrooms and other areas where there is a risk of electrical fires. Surge protectors are designed to protect electronic devices from voltage surges. Voltage surges can damage or destroy electronic devices. Surge protectors should be used to protect sensitive electronic equipment, such as computers, televisions, and stereos. Extension cords should be used sparingly and should not be overloaded. Overloading an extension cord can cause it to overheat and create a fire hazard. Make sure that the extension cord is rated for the amount of current that it will be carrying. Damaged electrical cord should be replaced immediately. Damaged cords can create a shock hazard or a fire hazard. Never attempt to repair damaged electrical cord yourself. Always hire a qualified electrician to perform electrical repairs. Electrical repairs can be dangerous, and it is important to have them done by someone who is properly trained and experienced. Carbon monoxide detectors should be installed in all homes that have fuel-burning appliances, such as furnaces, water heaters, and stoves. Carbon monoxide is a colorless, odorless gas that can be deadly. Make sure that the carbon monoxide detector is working properly and that the batteries are fresh. Smoke detectors should be installed in all homes. Smoke detectors can save lives by alerting you to a fire. Make sure that the smoke detectors are working properly and that the batteries are fresh. Develop a fire escape plan for your home. Make sure that everyone in the family knows the plan and practices it regularly. In the event of a fire, get out of the house immediately and call 911 from a safe location. When working with electricity, it is important to be aware of the potential hazards and to take precautions to protect yourself. Always turn off the power to the circuit before working on it. Use insulated tools and wear appropriate safety gear such as gloves and eye protection. If you are not sure how to do something, ask a qualified electrician for help. Remember, safety should always be the top priority when working with electricity. By following these safety tips, you can help to prevent electrical accidents and injuries.